Hello everyone. In the previous video, we were solving the question 3 and we have done till the third part. So in these questions, what we needed to do, the sets were given in the set builder form and we needed to write them in basically in roster form. So let's jump into the fourth part. So fourth part is D is given. D is equal to X such that X is a prime number which is divisor of 60. Okay. So divisor of 60 means that the numbers that divide 60. So first let's write the numbers that divide 60. So what are those numbers? The number that divides 60. What are those numbers? So 1 divides 60, 2 divides 60, 3 divides 60, 4 divides 60, 5 divides 60, 6 divides 60. 7 does not divide 60, 8 does not divide 60, 9 does not divide 60, 10 divides 60, 11, 12, just 12 divides 60? Yes, 12 5s are 60. 13 does not divide 60, 14 does not divide 60, but 50 divides 60. And then 20 divides 60, 30 divides 60, and then 60 divides 60. So basically, you just need to see if you can find something that a natural number that when you divide a natural number or an integer, when you divide, you will get 60. So for 2, you have 2 into 30. For 3, you have 3 into 20 is 60. So it means that these numbers divide 60. Okay. Now you need to find the prime numbers that divide 60. So these are all the divisor of 60. So you simply need to find all the prime number from this set, and that will be your D. You need to find all the prime number, and that will be your D. So does one a prime number? So we do not consider 1 as a prime number. Even though the definition of prime is that a number should only be divisible by the number 1 and itself, but we do not consider 1 as a prime number. So what would be our D? D will be 2, 3. Now 4 is not a prime number. So 5, 6 again is not a prime number. 10 is not a prime number. 12 is not a prime number. 15 is not a prime number. 20 is not a prime number. 30 is not a prime number. And 60 is not a prime number. So there are only 3 elements in this set: 2, 3, and 5. So these are prime divisor of 60. Okay. Now let's see the next example. E is equal to, before moving to the fifth part, just wanted to clear a confusion if you have. Prime number are natural numbers. So prime numbers are not integers. So that's why when I was writing the divisor, I didn't write plus minus 1 or plus minus 2, because they are divisor, but they are not a prime number. So I just write the positive divisor of 60. This is positive divisor of 6, because we needed to choose prime divisors from this set. So I didn't write the negative divisor. Hope this clears if there is any doubt. Okay. Now let's see the set E. Okay. What is the set E? The set E is the set of all letters in the words trigonometry. Okay, so this is a simple question. We simply need to write E is equal to the word in the trigonometry. Again, you need to remember that the set should be well defined and distinct. So it is a well defined set. We just need to remember that all the elements should be distinct. So T, R, I, G, O, N. Now we will not repeat the next letter O. M, E, T. Again, we have already wrote that letter, so we will not write T. R, we have wrote that letter, so Y. So this is the set of all letters in the word trigonometry. We do not need to write T twice or R twice or O twice. Okay, so let's see the last part of this question. F is the set of all letters in the word better. Okay, this is also very simple. We simply need to write all the distinct letters of the word better. So B, E, T. We will not repeat the word letter T and E and then R. So there are four letters in the word, four distinct letters in the word better. So this will be the set. Okay. Now let's move on to the next question. Which of the following, write the following sets in the set builder form. Okay, so we have already discussed what is a set builder form in a previous video. So let's write this. So we have first is the first part. In the first part, we have given this set. So for set, you can also write in the curly bracket and you can also write it in a small bracket. So 3, 6, 9, 12. And that's it. If you look closely, what is this? This is 3 1s are 3, right? 3 2s are 6, 3 3s are 9, 3 4s are 12, till 4. 3 4s are 12. Okay? So let's write. This is a set in which x such that x is equal to 3n, where n goes from 1 to 4. Okay? And if you have any confusion in the like the sign of this thing, less than, greater than, less than or equal to, greater than equal to, I have a video on the channel about the number line, and that could clarify any doubt if you have. Okay, so let's see the next question, next part. The next part is 2, 4, 8, 16, 32. So we need to find a common characteristic first, and then we can write it in the builder form. Okay, so 2, 4, 8. 2, 4, 6 is not here, so it is not the set of even natural numbers, right? It is something else. So we have 2, then we have 4, and then we have 8, and then we have 16, and then we have 32. Okay, so this is 2 to the power 1, this is 2 to the power 2, this is 2 to the power 3, this is 2 to the power 4, and this is 2 to the power 5. So this is the characteristic that they are in the form of 2 to the power something. So let's write this set x such that x is equal to 2 to the power n, where now your n range from 1, 2, 3, 4, 5. So your n goes to from 1 to 5. Okay. Now let's see the next example. The next example is 5, 25, 125, 625. So we have already solved this. So I think we should have an idea. Try to pause the video and solve it by yourself. Try to find the common characteristic, and then you can resume the video and see. So this is 5 to the power 1. This is 5 square. This is 5 cube, and this is 5 to the power. So it's simple. You can write it as x such that x is equal to 5 to the power n, where your n varies from 1 to 4. Okay, let's see the next part. 2, 4, 6. So this is easy. This is the set of even natural number. So this is x, such that you can write it in two forms. Either x is equal to 2n, where n belongs to natural number, or you can simply write x such that x is an even natural number. Both would be same thing. Now let's see the next and last part of this question. 149 and 100. Okay. So let me first write the set 1, 4, 9, 10 and 100. Okay, so there was no 10 over here. 1, 4, 9 and then 100. If you look closely, this is nothing but the perfect square. So this is 1 square, this is 2 square, this is 3 square, this is 10 square. Again, I am saying it again and again. Please pause the video and then find the characteristic by yourself. So this would be x, such that x is equal to n square. Where should your n varies? It should varies from 1, 2, 3 up to 10. So the value of n varies from 1 to 10. So this is your sets in the set builder form. Okay, let's quickly see the next question. Okay, so in this question, we need to list all the elements of the following set. So A is equal to x, such that x is an odd natural number. We already know that the natural numbers are what? 1, 2, 3 and so on. And odd means it should not be divided by 2. So this would be 1, 3, 5, 7 and so on. B is equal to x, such that x is an integer, meaning this is what? Minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. And it lies between minus half and 9 by 2. So minus half would be between 0 and minus 1. So after minus half, the integer would be 0. And then 1, 2, 3. So this is 4.5. So the integers will be 4. And then 5 would be greater than, and that's why it would not belong to the set B. Now C is equal to x, such that x is an integer and x square is less than 4. Okay, no problem. So let's see. 0 square is 0. Plus minus, either plus minus 1 square is 1. So both plus and minus 1 would belong to the set. And then plus minus 2 square is 4. So both plus 2 and minus 2 would be in the set. Now plus minus 3. So I am writing plus minus 3. It means I am saying both together. Plus 3 and minus 3. This is 9. So it is not less than. So the element of this set C would be 0, plus minus 1, plus minus 2. Okay. Or you can also write minus 2, minus 1, 0, 1. Let's see the next one. D is equal to x, such that x is a letter in the word loyal. So it is very simple. It is L-O-Y-A, and we will not write L again because the element of the set should be distinct. As for E is equal to x, such that x is a month of a year not having 31 days. So what are those months that does not have 31 days? January have 31 days. February does not have 31 days. So February would be over here. I will write them in the short form. And then March does have 31 days. April does not have. And then May does have. June does not have. July and August both have 31 days. But September does not have. Then October does not have 30. So to solve this part, you should know which months of the year should have do have 31 days or do not have. Okay, let's see the last part. F is equal to X such that X is a consonant in the English alphabet which precedes K. Precedes means which should come before K. So, consonant in the English alphabet are all the alphabet except A, E, I, O, U. All the alphabet except this, and it should precede K. So, let's write this set. A is not here. B, C, D, E is a vowel, so it's not a consonant. Then F, G, H, I is again a vowel, so it's not a consonant. J, and then it should proceeds K. Now, does K precedes K? So it is kind of this question: does X is less than does 6 less than 6? So no. So K also does not precede K. So we will not write K here. Okay. So this will be, we will stop here. Now pause the video and see if I have made any mistake in this X. Okay. So there is a small mistake. What's that? You need to, when you are studying algebra, you need to be very clear with the language and the symbols. So here F was X such that X is a consonant in the English alphabet which precedes K. It was a small alphabet K. So when we were writing our answer, how should we write it? We should write it like this: B, C, D, F, G, H, and J. We should not write it like this because they were not talking about capital K, they were talking about a small k. And if I would have wrote this answer directly, you may not have thought that. So that's why I did it. Okay, let's see the last question of this chapter. What's that? Match each of the set on the left in the roster form with the same set on the right described in the set builder form. So we have solved an example also like this. So we will first solve the sets in the right side. Okay. The sets that are given in set builder form, we will first write them in roster form and then we'll match them. Okay. So X, such that X is a prime number and is a divisor of 6. So divisor of 6 are 1, 2, 3 and 6. Now we need to choose prime numbers from this. So this is 2 and 3. So this matches to the second option. Okay. Now X is an odd natural number less than 10. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on. So odd natural number 1, 3, 5, 7, 9. 11 is greater than 10. So we will stop here. And this matches to your option 4. Okay. Let's solve the C part. X is a natural number and is a divisor of 6. So we have already written all the natural divisor of 6. 1, 2, 3 and 6. And if it was not a natural number, it was an integer, then your divisor would be plus minus 1, plus minus 2, plus minus 3 and plus minus 6. So this matches to your first option. Okay. Your C matches to your first option. And then X is a letter of the word mathematics. There is only one option, but still let's check this. M, A, T, H, E, and we will not repeat M again. We will not repeat the A word. We will not repeat the T word. Then I, C, S. So this matches to your third option. Okay. So this concludes our exercise 1.1. In the next video, we'll learn a new topic of the set, the empty set. and finite and infinite sets. So please keep watching the video. Please do comment also. If you have any query or any question or otherwise, please do comment also. Please like, share and subscribe. Thank you for watching.